Hello everyone, I'm Aarti Malhotra, moderator for this session. Hope you're enjoying the Machine Learning and Production Summit so far. I have the privilege to introduce Ms. Milecia Mcgregor, a developer advocate at Iterative.AI, a California-based company creating developer tools for machine learning. She is a senior software engineer, an international tech speaker, and a scientist. She has done her master's degree in mechanical and aerospace engineering and has published research in machine learning and robotics. She will try to make anything with JavaScript first. In her free time, she enjoys learning random things like how to ride unicycle and playing with a dog. Please join me to welcome Ms. Milecia to present her work on how to add reproducibility to your machine learning projects. If anyone has any questions, please feel free to post the same in the chat. We will have a Q&A session after the talk. Over to you, Ms. Milecia.
All right. Hi, everybody. I'm going to attempt to do the crazy thing of sharing my screen today. So my name is Milecia Mcgregor, and I'm a developer advocate at Iterative.AI. But my background is kind of all over the place, like you heard in that nice introduction. So today I want to talk to you about using reproducible experiments to make better machine learning models. I always like to start my talks off with a quick overview so that you know exactly which parts you want to focus in on. But first, we'll go through a little background on tuning hyperparameters and why that's so important. Then we'll talk about using DVC a bit so that we can add that reproducibility to our experiments. And then we'll implement a really simple grid search with DVC on a particular image classification problem. And then we'll implement random search. And finally, I'll wrap up with a few key takeaways, which are just a couple things that I really hope you get out of today. So to get started, let's talk about a little background on hyperparameter tuning. So hyperparameters are the parameters that define your model. So if you have something like a neural net, this a hyperparameter for that might be the number of hidden layers in that neural net. Or if you have something like a random forest classifier, maybe your max depth is a hyperparameter there. So these are the parameters that define the actual model. And the process of finding the ideal model, or part of that process, is called hyperparameter tuning. This is where we take all of the parameters that make up our model. So if I take the random forest classifier, for example, this has hyperparameters like n estimators, the min samples that you split, the number of jobs, the max depth, and a bunch of other parameters that you can play around with. So when we do that, we're going through this iterative process of trying out different values for those parameters to see what makes our model give us the best accuracy, or whatever metric it is you're measuring, the lowest loss for our problem. So an important thing to note, because this comes up sometimes, hyperparameters cannot be directly trained from your data. Remember, these aren't the values that you're looking for as a result of your training. These are the parameters that build the model you do training with. So the way that we figure out if a hyperparameter value is a good one is we build the model with a particular set of hyperparameters, and then we run our training through that model. And based on things like our accuracy or the loss or any other metrics you're measuring, maybe you're handling like rock AUC curves, This tells you how well your model is doing. And if you see that you have pretty good accuracy and it's associated with a certain set of hyperparameters, then you know you have a good model. So that's just a quick background on hyperparameter tuning. So let's jump over to DVC for a little bit. When you're working with a machine learning problem and you're trying to get this great model, you end up making a lot of changes in a lot of different places. So you might update your code. Maybe you started with a neural network and you want to see how well a random forest classifier would do in comparison. That's a pretty big code change. And a lot of times we track this stuff with Git, but that can get really messy when you're trying to go back and figure out what exactly gave you this great model that you're trying to deploy to production. So on top of code changes, maybe you make hyperparameter changes or you change the data you're working with. Maybe you get more data sets or you find out that you can clean some of your data or relabel things. All of these changes go into an experiment. So as you're running these experiments, we try to keep track with Git, and maybe you have some Google Drive that has like 800 different zip files with the data set that you were using for a specific experiment. It gets pretty hard to manage really fast. So that's why we use tools like DVC. It tracks all of those changes for us. And when we find that perfect model, you can see the exact code, hyperparameters, and data associated with that model being created. So this makes it a reproducible experiment, which means at any point you can take an experiment that you've run and completely reproduce it end to end, which I don't know if you've ever had one of those like, oh my gosh, I finally got the accuracy above 50%, but I have no idea what changes. Was it was it this code change? Did I update that hyperparameter? Um, I don't know what I did to get this great model. So you can't make it again, which means you can't deploy it to prod. That's why reproducibility is so important. And one of the good things about DVC is you don't have to add anything to your code. A lot of other, I guess, packages or tools like this, you end up needing to add these libraries to your code, and then it slows down the training process. And maybe you have to add a whole new stage to your ML ops pipeline, and it makes it harder than it needs to be. So with DVC, as long as you're logging metrics, which you probably are, in something like a CSV or a JSON file, DVC can handle all of your metrics for you, all of the tracking for you, and it gives you different ways to look at everything. So now that you know a little bit about reproducibility in DVC, let's jump into grid search real quick. So a grid search is one of the methods that we use for hyperparameter tuning. And basically, you get all of your hyperparameters and you get a certain set of values for each one of them, and you iterate over every combination. So grid search is an exhaustive search. Every value for every hyperparameter will be tested. So you don't have to worry about missing anything. It's a very thorough method. But with that being said, let's switch to a live demo. So I'm gonna try to share this other part of my screen. Ha! Did it. Switching screens today is going well. So this is just a quick little toy machine learning thing that I set up. And it uses this random forest classifier to tell us what certain images are. But that's not really the important part. I do want you to notice that there's nothing DVC related in here. This is just a regular old training script. But a little background just to show you what is happening as we go through our experiments. We have DVC initialized in this repo, and it's all here in this .dvc file. So this has everything that we need to start tracking all of those changes we were talking about. And then here in the DVC YAML, we have different stages for our machine learning pipeline. So basically, we pull in some data, we featurize it, and then we start training our model. And at the very end, we have this evaluate stage, which is where we get all of our metrics. We'll take a look at some plots a little bit later. And coming back up to the training, I want to point out these params because these are our hyperparameters for this training stage. These values get read in from the params.yaml file for this train step. And this is a different approach to a lot of machine learning projects because a lot of times your hyperparameters are in some giant config file and you have to search through it and make sure that you're committing every change that you make every time you make one, even the revisions. But with DVC, you don't have to worry about that. It's very modular. So if you come in here and you change one of the hyperparameters for the training stage, then because of the way we have our pipeline defined, it will only run the train and evaluate stages. So since we didn't change any hyperparameters that have to do with the data, we don't have to go through that preparation and featurization. We don't have to go through that again because nothing changed there, which gives us back a little bit more time to do more experiments. So now that you see kind of how DVC works and where we put our hyperparameter values, let's look at this grid search script. So this is a very, very small grid search just because I don't want to take, you know, too much time executing the different experiments. But this is generally how it works. You have your hyperparameters that you want to tune. You give them a certain set of values that you want to iterate through. And then you iterate over all of the possible combinations of those hyperparameter values. But this is where DVC comes in. So what's happening here is we're actually queuing experiments. And that means we're setting up multiple experiments that we can execute either locally on our computer or with the right configurations, you can execute this in a cloud environment, like using something on Azure or AWS. But the main thing is we can queue up these experiments so we don't have to execute them one by one. We don't have to manually input all of this. And the way that we do that is just with a quick command. We'll run DVC. Oh, wait, we don't run DVC anything. We just execute this script first. So I'm going to execute this grid search.py and make the terminal a little bit bigger. So what's happening here is DVC is executing this run queue command, and we're setting a different value for each hyperparameter every time. So we have all of the possible combinations for these hyperparameters right here. And something else I want to show is, what if you just want to see what experiments got queued up? We can run dvc exp show. And this brings up a table with all of these experiments queued. And if I tab over, you can see all of those hyperparameter values. So what I'm going to do, because we'll be looking at that table a lot, I'm going to go ahead and clean it up a little bit so that it's easier for us to read. So I'm just going to include the parameters that we're training here, well, that we're tuning. So that's that NEST and our min split. So now when we look at that table, it's a lot easier to read. But you can see every possible combination of those values is already there. And to execute these, the fun part, we'll run dvc exp run dash dash run all. And let's say that you had some resources that you wanted to use. So maybe you want to execute these in parallel. So using this dash dash jobs flag, we're going to run 2 experiments in parallel until we get through this whole queue. So I know it looks like the screen is just twitching a little bit right now, but it's getting ready to run all those experiments. So the way DVC works to track everything, it holds the specific values for each experiment in a custom Git ref. So when you're making commits to GitHub, DVC in the background is tracking which hyperparameter values, which code commit, which data set was used for each and every experiment in a custom Git ref. That's how you're able to keep track of everything without clogging up your GitHub with a bunch of very small commits that make it hard to figure out which changes went with which experiment. Not that that's happened before, but it's definitely happened before. And this just makes it easier to deal with. So something I want to show you while the training is running in the background is that the only thing we do, we load in our hyperparams from that YAML file, and then we're outputting a few different metrics. So in this case, we're outputting some PRC values. So we get that from our training. Then we're outputting some rock curve values. And lastly, we're outputting an average precision and this overall rock AUC value. So these are going to be used by DVC to tell us what the metrics were for that model for that particular experiment. So I think this is getting close to being done. We didn't have a whole lot of experiments, but we did have, enough to make it run this long. While all of that is running, something else that I can show you is if we open up our plots. So I just wanted to show you what this plot looks like. This is just one of the things that you can use to visually check how your model is doing. So with the DVC, those 2 metrics files that we looked at, the one that had the PRC and the other one that had the ROC values, this is what those plots look like. So it's just telling you how things change with respect to the metric values that we decided to go with. But our experiments finally finished running. So I'm going to clear this terminal and let's take a look at that table again. Okay, so I still got some queued for whatever reason. I'm not going to bore y'all with debugging, but you can see up here, after those experiments ran, we have the different metrics associated with each combination of hyperparameter values. So if you look through these real quick, it looks like this model had the best average precision. So maybe we would want to start our next set of experiments with this particular set of hyperparameter values because they seem to give us the best outcome for our model. But that's how grid search works. So thankfully, our random search isn't a whole lot different. And we'll talk about random search real quick. So it takes less time than grid search because it just hops around random values that you give it from that set. And a lot of times it performs better than grid search if you give it a similar amount of time, just because it checks a wider range of values that it would take grid search a lot longer time to get to. But we'll take a quick look at what this is like with DVC. So I have another script in here that does a random search for us. And basically, you see we have it set to run 5 experiments. It's going to choose some random integer for our NEST value, and it's going to choose one of these values randomly for our min split. And if I execute this, it queues up experiments exactly like the grid search did. So we got our 5 experiments. And if I look here at this table and make this bigger, so you'll see where the random search comes in because these are hyperparameter values we have not used before. But before you execute a queued experiment, you might want to do a check like this just to make sure that the values are reasonable within what you are looking for, and to see if there are some experiments you might want to leave out, if you want to push them to the cloud, if you want to execute locally on a GPU, on a CPU. You have a lot of options with these queued experiments. So you've seen how random search works, you've seen how grid search works, you've seen plenty of experiments get run. So now I'm gonna go ahead and switch back and wrap up for the day. So I just want to leave you with a few key takeaways. And basically, tuning hyperparameters quickly will help you make better models a lot faster. Because when you're able to go back and reproduce experiments, you have a certain kind of confidence with going forward with more experiments because you know at any point you can come back and pick up where you left off. And then, of course, DVC is it's a really good tool to use if you're doing any type of model creation because it tracks everything for you. So it helps you tune your hyperparameters, but it also versions your data. It also tracks your code changes. And that way you can even share experiments with other machine learning engineers to get feedback. And you don't have to send them a GitHub repo and complete access to all of your data. You can send them the repo, of course, but then you can just send them this specific DVC experiment to get started. They don't have to figure out how to reproduce what you did. It's already there. And lastly, don't be afraid to try new tools. There are so many tools that make things easier for us now that we don't have to reinvent the wheel. It's okay to use what's already available. It doesn't mean that you're cheating. It doesn't mean that you took a shortcut. This is why we make the tools, so that we can get through the problems faster. The software is only a piece of it, but we're actually trying to solve problems. So if a new tool would help you solve a problem faster, don't be afraid to give it a try. But that's all I have before we do some Q&A. And if you do have any questions you think of later, feel free to reach out to me on Twitter at FlippedCoding, or you can reach out to the whole DVC team on Twitter at DVC.org. So if you have any questions for me, please feel free to drop them in the chat.
Thank you, Ms. Milecia, for the inspiring talk. Yes, participants can post your questions and we'll try to ask to Ms. Milecia. In the meanwhile, I had a couple of questions. So you mentioned we can version the data. Can we version the results to be able to compare to like previous models? Um, yeah,
Yeah, so like that's part of the experiment tracking. Let me switch back to VS Code real quick and get a little technical. So if I come here in this DVC lock file, it shows you pretty much everything that is tracked in each stage. Um, Basically, we get this MD5 that has the data associated with the specific experiment. It has the metrics associated with that experiment, and it has the code and any hyperparameters associated with that experiment.
nice. Thank you. And what were the like top challenges you faced during experimenting with DVC? And are there any computational constraints?
No, none that I've run into. It really doesn't like do anything except tracking.
Mm,
So it's not taking any extra resources or making the training time longer or more complicated, if that makes sense. It's
right.
just working with the files that we already log metrics to. So I'm trying to see, where is that? In here we have, what, yeah. We pull in some arguments and that makes up these different files so that we log the specific metrics we're trying to track to those files. That doesn't have anything to do with DVC. That's just a regular old file creation with a training script.
So anyone new who wants to try DVC out, there are resources available online, and we can try using do a POC.
Oh, definitely. So the best place, I'll drop a link. If you start with our docs, there's a really good get started example to walk you through kind of like the philosophy of DVC and how we handle experiments and all that good stuff. And we also have a really friendly Discord community. So we have students from all over the world that pop in and ask questions and help answer each other's questions. We have monthly meetups. We have a lot of things for anybody that wants to get started.
Thank you. That is awesome. Okay, do we have any more questions?
And here's a link. I don't think that's the right link. I always get that one wrong when I get our meetup. But this is a link to our next meetup where you can keep up with everything. I'll be talking about pre-trained models next time.
Oh,
Tomorrow actually.
okay. And the Twitter handle is you mentioned DVC.
The Twitter handle for DVC, I'll drop a link to that.
Sure. Thank you. That's awesome. Okay. Thank you. I think uh, the session time is up. So on behalf of MLOps World team and wonderful audience here, I would like to thank you once again. I encourage attendees to visit our partner booths to enter in some exciting giveaways. Have a great day, all. Thanks, Miss Militia.
All right, thanks for having me.
Thank you.